Note, incidentally, this equation incorporates a directivity correction. The horizontal axis is effective sound speed gradient, calculated between 0 and 120 meters, and given by equation 2.5 on page 15, described as the dimensionless vertical gradient of wind speed. The paper does not give full details, but it's reasonable to assume that sound measurements would be taken at points consistent with the predominant downwind direction. The red line for no snow cover is drawn through the median delta L, and the vertical bar shows one standard deviation of the results. It is that will take into account variations in wind direction. Wind direction has nothing to do with the horizontal scale that Mr. Trinick referred to yesterday. Contrary to his assertion, minus 0.06 on figure 4.4 does not indicate downwind conditions. It indicates a negative sound speed gradient, otherwise referred to as a thermal inversion. Thank you.
That still doesn't explain whether it's legitimate to go up both sides of the zero. Is it not?
It does, sir.
Well,
May
I
yes,
ask
sir.
you a question?
Please do, yeah.
You start with 0, which presumably is you have neither positive nor negative. So the measured speed at 120 metres and 0 is the same.
Yes.
Oland's headline figures are relying upon the difference between one extreme of the scale, which is when you have your inversion, where you have a significantly lower, a negative delta L, and at the other end of the scale, where you have a sound speed gradient in the positive, so what you'd expect, 120 metre height, much higher wind speed than at 0. I appreciate what you're saying. It's not to do with wind direction, it's to do with the difference in relative wind speed between 120 and 0, and sometimes that can be what you wouldn't expect in the negative, the inverse. But surely the point is still valid, Mr. Trinick asked, which is it legitimate to take as the range, the 6 dB or the 14, both sides of that continuum? Should you not be, in fact, saying it's either between 0, when there is no difference, and the extreme negative, or between 0 and the extreme positive? It's not legitimate to take, because you couldn't experience the full 6 dB difference at any one point. It couldn't simultaneously be both ways.
Yes, so there is a valid point to consider there, but it is not a point that is related to what was suggested yesterday, that the negative meant downwind direction.
I appreciate that, but it's my question.
Your
it still goes to the question
valid,
whether Mr. Oland was, whether his headline figures are perhaps a little bit overexcited.
Yes, I mean, we can look at that, and we can look back at the figure. But I think the point is that your normal conditions typically are not thermal inversion. So normally, you're not on the negative side.
And it's the negative side, you accept that it's the most dramatic.
Yes, absolutely, absolutely. So if you looked at figure 4.4 and the no snow cover, for example, you might get a figure round about, you might say 4 dB instead of 6, for example. You can, if you go somewhere in the middle. Is that a reasonable thing to say, for example?
The question, please.
Yeah, All right.
Old-fashioned way. If you go to figure 4.2, which is on page 21, this shows mean measured downwind sound speed profiles. If you see that the sound speed in the x-axis, which at 0 is 335, and then as wind speed increases with height downwind, say at 20 meters, you can see that the sound speed has increased. If you go up to 40 meters, it's increased more. Going back to figure 4.4, that's my point, that You can't experience both at once. You either experience a downwind propagation or an upwind propagation, so that the correct measure is to start at 0 if you're looking at downwind and see what happens above 0. That's a 2 dB difference, not a 6 dB difference.
What?
And it's not, I'm not criticizing the report by Oland. For his purposes, he didn't need to separate upwind and downwind. It's your use of the report and what you draw from it that we take issue with. And my suggestion is that you made the wrong use of it because you've added upwind and downwind. You can't experience both at once.
Could you explain, please, Mr. Trinick, when you refer to 0 on figure 4.4 and relate that to upwind or downwind, what are you referring to? Are you referring to 0 on that horizontal axis?
Yes, on the x-axis.
Well, then you're entirely wrong, sir.
Well,
you haven't understood this paper. And if you were going on the advice of your expert, then he also, I submit...
Well, can I just suggest a little less arrogance and more attention to my question? I'm sorry to be blunt, but I've had enough. Now, look, the basic proposition I'm putting to you is, and I'll put it one more time, and then we'll leave it and move on, is this, that if we're looking at sound speed gradient, and that sound speed gradient is increasing, it can only increase in the downwind direction. It can't increase in the upwind direction, it gets less. And therefore, adding 4 dB to 2 dB, if you've done, is entirely incorrect. The correct measure is from 0 upwards to plus 2 dB. Now, I'd like just a clear answer without any more insults to me or to my witness on that point.
I have to apologize, Mr. Trinick, but I have to say very firmly, I am not providing any insults. I am merely saying quite clearly what the facts of this paper are. And I would request that you go to, let me just find it, because there is confusion over what is on that horizontal axis. So the horizontal axis, if we look, and please do not confuse positive assertion of a point with insult. It is not intended. It is merely saying what I, as an expert witness, firmly believe. I could be wrong. It is my firm opinion I am not. So if we look at figure 4.4, it describes the horizontal axis as effective sound speed gradient, calculated between two heights. Now, if you move to page 15, and equation 2.5. Equation 2.5 and what is described below, it says theta m is the dimensionless vertical gradient of wind speed. That has nothing to do with wind direction, upwind or downwind. It is simply whatever direction the wind's going in, what is the gradient? What is the difference as you go up in height?
Fine. You have my point, sir. I'm not taking me further. Thank you.
Do you accept my point or not, Mr. Trinick?
I don't
And if you do not, please explain why you do not.
That's not Mr. Trinick's. What I was trying to shortcut, that's why I intervened. I was trying to shortcut to get to Mr. Trinick's, the basis for Mr. Trinick's point, regardless of whether you agree with him about wind direction or not. It seemed to me that the legitimate point is to look from the distance away from the 0 point. So when 120 metre wind speed is the same as 0 wind speed, and to go along the positive side of the x-axis and look at the difference between, for delta L, so the difference between what you expect and what you actually get in terms of sound power level. And I think Mr. Trinick's point was you're not getting more than about a 2 dB increase and it's not legitimate to include the increase that would be attributable to going in the other direction, which is where the inversion that you talked about, where wind speed is higher at 0 than it is at 120, because you can't have those two things occurring simultaneously. So all you're ever going to get is plus 2 dB, according to Oland. Is that not right?
I don't think that's, with respect, I don't think that's correct, sir. What we're actually looking at, if you consider what we presented, I presented yesterday, and the variation in wind shear, there are some parallels. And in effect, most of the time, your average is somewhat higher. It might be, I don't know, well, certainly from one of the figures I presented of typical conditions in the UK elsewhere, the average might be around about 0.23, so slightly higher than the standardized value. So you're in that region, and the parallel on this paper, and I cannot pretend that I can say accurately how that would relate directly to it, but I think in practice you're normally somewhere on the positive side, somewhere between your 0 and your 0.13. So I would agree with you entirely. If we're looking at average conditions, we might look somewhere in the middle there for the sort of average that you would get in the normal range. So you might be, let's take 2 points from the right-hand side, then your difference between the left-hand side, where you were at minus 0.06 on the x-axis as a gradient, sound speed gradient, the difference between there and that point is about 4 dB. Now, interestingly, if you look at what the ISO prediction was for core glass, and you look at the green curve in the second shutdown, I think you will find that the difference, and I'm going from memory here, but I think the difference was about, interestingly, it was, I think, 6 dB, but I believe, I'm correct, I said yesterday, we need to check this, I believe that the prediction there did not have the 2 dB uncertainty level. So if you added the 2 dB uncertainty level, it would push the blue curve that we had there, which was the ISO prediction, up by 2, which would make the difference between that and the green curve that they calculated in the second shutdown, 4 dB, which is compatible with what is here.
If you're going into the realms of negative sound speed gradient, you're actually getting results that are quieter at the receptor than you would expect. Is that not the case? It's because delta L is becoming negative, considerably negative.
You are correct.
So does it matter? That's not a sign. You'll forgive me because I'm not an acoustician by any stretch of the imagination. But if you are facing this situation, which I think you say is atypical,
yes,
and it's an inversion,
yes,
that would be to the benefit of the receptor. It's not a reason to doubt the reliability of the figures, because it's a bonus. In the unlikely event that you have an inversion, the effect on the receptor will be they're actually a lot quieter than you would expect. And appreciate you say that happens very infrequently, but perhaps I'm being thick, but I'm not seeing any of that as a reason to use that end of the scale as being relevant to or undermining the applicant's case. As I say, I may be missing the point. I just don't see the relevance of those atypical, the left-hand end of that drawing, the temperature inversion or negative wind shear, whatever you want to characterize it as.
I think so. You've actually been very suspicious. I think you are actually correct in that. I need to think about that carefully, but I think you may well be correct in that. But the zero on the on the vertical line, the zero, which actually goes through that left-hand point, is what is their best prediction. And I know Mr. Trini queried that this didn't follow the ISO prediction. And I cannot comment. I don't know precisely what prediction they use. What I can say is in the references, they do refer to ISO. So a comprehensive study like this with all the meteorologists and acousticians, I would advance that they would use as best a prediction as they feel they sensibly can, whatever that happens to be, whether it's ISO or it's one of the European ones or whatever. And I think what this is saying, and you quite possibly are correct, we've got the zero line, which is zero horizontal line on the vertical axis, and that is what their best prediction is. And what this is saying is that the difference from the best prediction and reality can be, as a maximum, 6. But you are right. That's on the right-hand side, not the left, in terms of the speed gradient. And if I look back at how they've defined that formula, it's very nice to have a reporter that puts us right on the floor, sir. I'm the one that's the right report. Right. 2.5, let's see, no it's not, sorry. Let me get delta L is not 2.5, it is... Right, it's on page 19, and let's see what it says. It's defined as the difference between the measured sound power level and the calculated sound power level. So yes, when it's positive, the measured is higher than the calculated, which is what the graph is showing over on the right. Yeah.
It's almost flat. Well, it's a lot less severe than on the negative side. My point is on the negative side, it's good news to the receptor because the difference between measured and actual is actually in their favour. In those conditions,
yes.
Where there's the radical change, it's actually a quite an effect.
Well, that's particularly so on the snow cover. Yeah. And I believe that evidence given yesterday by Dr. Mackenzie did comment on that point with regard to the 2001 location. And he said it would be better. So we do have things that are tying together here. But I still believe, although I may have got the thermal inversion part of it incorrect, I still believe that what this figure is telling us is that you can get, and it appears it's on the positive side, not the negative side, in terms of sound speed gradient, you can get a difference of up to 6 on average or median dB in certain conditions.
And those are conditions that actually favour the receptor because they're making it quieter. And I appreciate
if it's at that end, yeah. But
on the other end, there isn't 60 dB.
Well, I think there is, sir, because if you look at the horizontal line going through that left-hand point, which is 68, the left-hand point 68, it appears that the agreement with the best prediction that they can do, they get agreement at minus 0.06. That point is a little 68 alongside it. Yes.
That could reduce other factors as all about what things are factored in and all that. If we start from the 0 point on the x-axis, which I think is where there is no difference in wind speed,
speed gradient,
at
yes,
hub and
yes,
ground or whatever. From that point, moving right, so that's effectively got no wind shear.
Actually, it's not. I'm sorry, my correction,
no.
sir, but it's not wind. It's not no wind difference. It's no sound speed difference.
Yeah, we're talking
there
about
are other things. They will be related, but there may be other factors.
I was being lazy.
Yeah.
We're talking about the effect on propagation of sound, but so at that point, there's no difference. Mm-hmm. As you move to the right, it's getting worse for the receptor because there is becoming a greater difference between 120-metre height and 0, and we're going up from about... this study says they found, I don't know, it's about 3, delta L is about 3-ish. So at that neutral point, they're saying we think we're finding sound power levels about 3 dB higher than the calculations would have suggested. Whereas you go right to the...
Is this at 0?
At 0
yes,
on the
yes,
X.
yes. Yeah.
And you go right to the far end of 0.13 or whatever it is, where you've got the 107 figure. It's gone up to about 5, plus 5. So again, that's only a 2 dB. I think this is Mr. Trinick's point. That's only a 2 dB difference, not a 6. And you can never experience the full 6 because you'd have to be having differences in sound speed between ground and hub that were simultaneously positive and negative, which would be impossible.
I think my point with respect to remains different. My point, corrected as you've kindly and rightly done so, is that the differences we're seeing on this graph, and the difference where they comment on up to 6 dB, which only comes in at the very right-hand side, so a high sound speed gradient. Whatever the sound speed gradient is, because we never measure this on site. We don't know what the sound speed gradient was in core glass. We don't know how it varies. All we know is we have a best prediction. And all we know here with certainty is they made a best prediction. And these are top acousticians with access to prediction methods around the world, whatever. They say, this is our best. And that is that line on the vertical axis, horizontal 0, which actually goes through the left-hand red point. So what to me this is saying is we know nothing about our sound speed gradient, just like at core glass. We know nothing about that. But we make our best prediction. And at certain times you can get up to a maximum of 6 dB difference, which happens to be at the positive end. That's all I can say. And I simply marry that, and I simply marry that with the other evidence I have referred to in, I think it's Hansen, where they referred to the study by Evans and Cooper, and they did point out that other paper writers or whatever have noted differences of the order of 6 dB. I know nothing more than that. That's all I can quote. So there is some evidence out there in this Swedish study and in that other one which we haven't delved into, that people do find differences of that order of magnitude. That is all I can say. I know no more. But there is that evidence out there. Thank you, and thanks for your help.
Sorry, Mr. Trini, I hate to crash in on your train of thought, but as you know, I need to actually write this thing down, so I need to make sure I have
You're asking the
get my head around
same
it.
questions in a different way that I was, and
If you need,
you got somewhere which I didn't, so I'm grateful.
do you need 5 minutes to regather your thoughts? Are you okay? Just
No,
to
I'm fine.
Yeah, thanks.
I think that takes us to the end of that line. I want to go now on to your report, Mr. Baker, at page 45. The top of page 45.
Yeah, I haven't got there yet, Mr. Trinh. Sorry. Takes a little, okay. And what section are you in, by the way? Section number?
Well, I don't know. It's page 45 of your report, which is 5116. 516. Are you there?
Yeah, I'm there.
By trial and error, you've got that sentence?
That's
By trial and error, a
Yes.
range of plausible wind shear values
Yeah.
can be tried until all points fall in a straight line and a plot of wind noise against V10. 3 questions on that.
Yeah, certainly.
What do you mean by trial and error?
Well, if you follow the GPG guidance on doing offsets when you have wind shear, you offset for high wind shear, you offset to the left by a certain amount, which will, what you're trying to do is get onto a line or a relationship which is equivalent to the ETSU one for actual 10-meter height. And you have to do that offset to get to it. Now, if you've got negative wind shear, which on the typical plot of the scatter of those shutdown points will only happen at the very top, if it happens at all, and typically during the daytime, but not necessarily. You could get some of that. So you have to say, well, what do I think is a reasonable and sensible line? And bearing in mind that I know that the very low points on the bottom right of that scatter equate to high wind shear, what I actually did is I looked at the points, I looked at typical sample points on each side or end of that scatter. And I said, what plausibly, this is what I think, and what plausibly will work. And I got the figures that I quoted in here. Now, that's of no relevance to my final finding. That is only what gave me the initial, that's only what gave me the initial indicator of what my controlling wind shear lines would be before I was given the data, before I had the detailed Excel information. That's what that says in the report. So there's no point putting that together to pieces. What we find is when I moved on and I used the actual data, Hayes-Mackenzie's data, and derived the background noise relationship in the manner I described yesterday, I actually found that approximation I did was very close to reality.
Okay, stop you there, because I just want to know about the trial and error. I think I've got the answer.
Yeah,
I want to rehearse it back to you to make sure it's correct. That, for example, looking at figure 6 on page 46, as I think I understood what you said, and I am struggling a bit here to understand it, you take a series of background, noise, not background, all noise plots.
All background noise plots, yes.
Well,
to derive what I've derived.
Well, looking at figure 6, only the red dots are certainly background.
Oh, sorry, I beg your pardon. Figure 6.
Only the red dots are certainly background.
Just, yes, correct.
Yes.
Yes.
So, for example, for line BB, there are no red dots there. That's all measured data. Yes?
Well, any points that fall on that line, correct. But
Yes.
No,
please follow me. No, because I'm trying to...
I can't answer. Okay, sorry.
No, I'm trying to...
Yes. Okay.
I want to do it in a small chunk so we understand it. So, we've got all measured data. We have a line BB. The trial and error involved, I'm not criticising trial and error, I'm just trying to understand it, is that you take, I think I heard you say, points at the extreme, and you try to construct the most logical line between those points.
So, not between those points. I try to correct the most logical line for what would be a relationship with actual 10-meter height wind speed rather than standardized, using the extreme points here and saying, well, what do I think the likely wind shear is, and therefore, in accordance with the GPG guidance, how much do I have, what offset do I have to do to get them over to a plausible line?
So where are the data that we look at in order to support your trial and error?
Well, certainly not, sir, in figure 6, because if you look at the top of figure 6, it's entitled Night Hours. And if you recall my presentation yesterday...
Now you give me a negative answer where it isn't. I didn't ask you for a negative answer. I said, where do I find the data? Where do I find it?
You find the data on... I'm struggling to see the relevance of this, but never mind. You find the data on whichever, it might be figure 12 or whatever, of Hayes-McKenzie's report, the one which gave all background noise.
So which
results.
report do we look at? Which Hayes-McKenzie report?
The first one of
April 19?
No, I actually used the one before that.
Well, if you're talking about November 18, it's not before the inquiry. So that's not going to help me.
Okay, it equates to, let's, what is it, April?
Well, it's the CD73, which is the April 2019 compliance report.
Have you got it, Mr. Campbell? May I have it?
Oh, I know. So no, stop.
I must put on record that I'm completely in the dark as to why an original report of November 2018 on some monitoring gets reissued 5 months later with no comment on why it's been reissued or what's been changed.
Let's continue with the line of questioning, please, Mr. Baker.
I'm just putting on record an observational, in fact, complaint I've got.
Right.
Okay.
Let me remind you of my question.
I have to remember the question. It's figure 15.
I'm going to remind everybody of my question then. It is simply, and I only want to know, where are the data that support, shall we say, line BB on figure 6?
Figure 15.
All right, I've been told to rephrase that question, so I will. Where are the data which support the equation at the top of page 45? Yeah, for the 2018 location, wind noise equals 11.9 plus 3.42 V10 dBA. The data I'm looking for are the data to support
15,
that equation.
Figure 15. I have said it a number of times. Figure 15. It's not changed.
Figure 15. Right, so this is in figure 15 and CD73 is all data points, measured noise levels, and this is directional. It's between 190 and 316 degrees. Right. What we're struggling with on this side is to know how you got, by trial and error, from that data to the, quotes, plausible range of wind shear, how until all points fell on a straight line. I don't understand. You have to tell us.
Well, I have described it a little earlier, but may I say, sir, that I think this is a waste of time, because it...
Actually, let me just say, this is fundamental to our understanding of your case. We need to know how you put your case together. You may think we're very stupid and it's a waste of time, but actually the reporter needs to know, and we need to know, how you put your case together. So can we have a polite answer to the question?
Certainly, certainly. And it's the one that I gave before. So I consider what is a sensible looking line, and in fact, if you would like me to attempt to show what I'm talking about, we've got these points here. We know, as I described yesterday, that as we go down, we are getting higher wind shear. And as we go up, we're getting lower wind shear. We know in general terms that the wind shear is usually on the positive side, so the zero lies somewhere up here. And that's precisely what I did. I looked at those points, I got a line which is more or less running sort of parallel to the upper ones there, something like that. And I then followed the GPG, and I said, what happens? We've got some high wind shear. What values of wind shear would we need to pull across to get onto that line? And I looked at the extremes there, and I looked at the extremes on the top. And I put plausible wind shear, what I considered plausible wind shear values to that, to get to a logical line. Now, please bear in mind, which is the point I was saying earlier, all I'm doing now, at that point in my assessment, is trying to find out what is reasonable before I have been provided with the actual data.
Well, okay.
And when I got the actual data, it was what I described yesterday.
Fine, but we're going beyond my question. We're looking
Fine.
at the initial trial and error exercise.
Yeah. Do you understand that one now, sir?
Well, I'm trying to.
But is it important? I did get it pretty much right.
If I may ask my question.
Okay.
It's trying to relate the equation at the top of page 45, which, for the 2018 location, that equation, how does that equation relate to figure 15?
It only relates by going through the various formula that I put down in the appendix and coming up with that equation.
At all events, figure 15 we can take as the source. Prior to receiving any more information, which you say validates your trial and error exercise, prior to that, figure 15 was the source for the various wind shear against background noise lines that we see in, for example, figure 6.
Well, it was and it wasn't, because at that point I did not have the April report. I had the earlier one, which is not before this inquiry, so I used what I had.
Right.
It is, I think it's similar in the same figure, because this April report has nothing in it whatsoever that talks about a previous report or about corrections.
All right.
It is not the normal way in which a report of this type is done.
Mr. Baker, it was a figure similar to that.
Yes, it was a figure.
Thank
That's
you.
all I can say. It was a figure.
Right.
similar
It's a
to that.
figure similar to figure 15
Yeah.
in a report, earlier report.
Yeah.
So I'm going to use figure 15 as a surrogate for that earlier figure.
That is absolutely
And let us assume for the moment that this figure 15 differs in no material respect from the earlier figure. Let us assume that for the moment. So let's use figure 15 as the surrogate source. If we can just assume that for the moment, then that figure is the source for the various, using language on page 45, where all plots follow a straight line, dragging wind shear values to the left until they match.
Yes.
But
Or
I'm
to
left
or
with,
to the right,
or to the right,
up
or
at the top,
or
yes,
to the right,
which will only be fractional.
or to the right. But the top right part of any individual curve is geared. Did you say to? No, I'm not sure we did. The top right point of any of these background noise lines plotted against wind shear is derived from precisely what? That's one I haven't quite understood.
Shall I attempt to describe again?
Yeah.
When one is doing something approximate, one uses one's professional judgment and does one's best. This is not a prescribed, documented method. It is professional judgment that does one's best, and that's what I did. And would you like me to describe it again?
Yes, please.
Right. I am aware, as I described yesterday, that as you go down, you are increasing. On a plot like this, you're representing increased values of wind shear. Now, if you actually go on the bottom, and you remember my family of curves, look at the points at the bottom. They're getting quite flat. So that's the line. So if you draw a line along that, and you come to somewhere then on your left-hand axis, what you are defining is where, roughly where your 0 point is, potentially. I'd have to get a straight line and see how much that...
Can I just stop, because just to help me understand.
Yes.
So that sort of line might equate that you've got a figure somewhere 16 where you have a lowest shear value of a highest shear value of 0.7.
Yes.
0.7.
Yeah, I think something like that.
0.71, I think it is on figure 16.
Let's see if I can do this here.
And I think that would equate to... Yeah, 0.71. And that actually does go through those bottom shutdown plots, doesn't it?
Yeah. I mean, here's a straight line along it, and
yeah.
I'm somewhere down here with my 0 point.
Okay.
And if I twist it round up to there, I'm
all right.
somewhere
Now, I do now see at least what you've done, and that helps.
Well, thank you, sir.
That's right. In any event, and I'll have to go with what understanding I've got. Let's see where that equation on page 45 leads us. If you go to figure 6 on page 46, I was going to take you through what's on the plot, but I think you've done it already yesterday, so we have a pretty good, we know what's what. So I can leave that question out. So that then leads us to figure 7 on page 50. Or initially, in fact, to paragraph 521 on page 49, which precedes figure 7. I have adopted a direct approach, a second paragraph of 521, to confirming the correct background noise V10 relationship for use in the equations derived. As shown earlier in presenting figure 6, when the wind shear is low, all the noise at core class 1 will be wind noise. And then you go on about LiDAR. But this leads then to the bottom of page 49, where you say when, top of page 50, now wind shear is 0, V10 equals V59, hence recorded noise plotted against V59 gives the background noise at core glass related to V10 at the wind farm. Some questions just on that. First of all, I think I know the answer, but I want to be sure. In the x-axis of figure 7, V10, that's V10 actual?
Yes, that is the ETSU actual.
Actual,
yes.
Where?
At the wind farm. At the wind farm, as ETSU requires.
Will you bear with me a minute? Yes, okay, I've got that. Oh, I understand that. So I think what you're saying is the data here back up your assumption as to the relationship between background noise and V10 wind speed.
Yes, what I am saying here is that, yes, this backs up the very approximate assessment I made before I had the detailed data.
Okay.
What I have used from this point onwards is this one in figure 7, the relationship that comes from that.
Okay.
As being the more accurate.
And, sorry, yes, just backtracking, therefore, the trial and error process led to what you did, and we've been there. The data you obtained, and we see in figure 7, at alpha is 0, you say below that gratifyingly the equation agrees remarkably closely. So this is what you're saying is the verification of your trial and error process?
Correct, sir.
Okay, fine. But of course figure 7 only presents data for wind shear of 0, and therefore, and when there's no turbine noise.
That is correct.
Right. And your hypothesis also assumes...
Well, actually, sorry, sir, just answering...
Your evidence, and strike hypothesis, I don't want to get into a debate. We say it's hypothesis, you won't, but let's call it your evidence also assumes that wind speed at hub height in conditions of alpha equals 0 will be the same as wind speed V10 at Cordglass Farm.
I merely do what ETSU requires me to do, which is to compare the noise that is recorded at Cordglass with the wind speed at 10-metre height at the wind farm. Now, the general blanket assumption is that until one has evidence otherwise, well, A, that's an acceptable thing to do. B, I don't need to know whether it is precisely the same at Cordglass. I cannot know that unless I have parallel wind speed readings there. But what I can and do know, and I do have some wind speed readings there, if you recall, not official ones, but I do have wind speed readings at 3.5 metre height. And I also have the residents' observations, which have been reported from very early on, that wind speeds at that time are low. You put all that evidence together, and the evidence of what is recorded at Cordglass at the times when we know wind turbine noise is being experienced, and everything actually fits together.
Okay.
So as I said yesterday, I have no evidence of there being markedly different wind conditions at Cordglass that cause noise that could be misinterpreted as wind farm noise when it actually is wind noise.
Let me put the question another way then, to try and close this. That is your evidence, or part of your evidence, dependent on an assumption that in conditions of alpha equals 0 on site...
By that you mean the wind farm?
Yes.
Yeah.
Sorry, yes, the wind farm. Then wind speed at V10, or V whatever, at Cordglass Farm will be the same as wind speed on site.
I do not say the same. I say similar.
Similar, okay.
Yeah, similar. There may well be variation, and I cannot answer what that variation is. But I can answer, and have answered, that the wind speed at Cordglass is low when the problem arises, and that fits with the data. That fits with what you get when you actually use the relationships I have applied and use them in accordance with what ETSA requires me to do.
Okay. Now, you see, that seems to me slightly counterintuitive in the absence of data for these reasons, that at best what you're indulging in is guesswork, because Paul's Hill 1 is about 2.4 kilometres from Cordglass Farm, and it's about 100 metres higher, about 95, I think. It doesn't matter exactly. And therefore, any presumption of a similarity between wind speed at Cordglass Farm and wind speed and the height is counterintuitive.
Mr. Trinnick, what you're actually doing is underlining the need for actually updating an approach that was set down nearly a quarter of a century ago, ETSU. Because all I'm doing is following what ETSU tells me to do.
So what's the answer
Now,
to my question?
If you are telling me that one should be measuring the wind speed at core glass,
No, I'm not. I'm just putting a question to you. You heard my question. Could I have an answer?
would you repeat it so I can make sure I understand clearly what you are asking?
That it is counterintuitive to say that wind speeds at a point about 95 metres lower and 2.4 kilometres from the wind farm are going to be similar. We simply have no idea, and it is at the least likely that wind speeds at the wind farm site are systemically going to be higher than those at Cordglass Farm.
Actually, I disagree. There is no specific evidence for that, and the reason is for a start, wind speeds are related to the thermal profile. We've just been talking about that sort of thing. So they are related to that. And what does control that to a certain degree is the temperature from the ground profile, from the ground level up. So you could say that intuitively there is a certain logic, and one can criticize any of this. There is a certain logic that wind speed at a certain height does actually bend to a degree and follow the profile of the ground. Now, if you go back to what ETSU's advice is, ETSU does make the point that the wind speed down at the receptor could be lower if you're in a sheltered valley. Well, I can assure you with experience of my clients living there and my visiting there, Cordglass does not qualify as a sheltered valley. You get a lot of wind when the wind's blowing coming through there.
Okay.
And therefore, again, I'm merely following ETSU advice. And furthermore, if what you are saying is correct, then the wind speed at Cordglass is going to be lower still. And therefore, there'll be less background noise in the trees and more wind noise.
That may be so. You've got an answer to the question, and I'll come back to that when we look at your wind speed information from the site itself, from Cordglass Farm. Just one point on figure 7.
Oops.
If you see figure 7 at 10 metres a second, background noise is about 53, I would guess, 53 dB L90.
Not sure what you're looking at.
Figure 7, 10 metres a second. 43, sorry, not 53, 43.
Oh, that's
Or 45, or
good. And I
thereabouts.
don't get results going up to 10, so I take it you're looking at about 9. I mean, we do need to be accurate. I think you'd agree in this if you're starting to quote particular figures at me. So I would say that is, we go up to about maybe 9.3, 9.4, 9.5 maximum. So you're talking about the right-hand end of that scale. And
That's right.
are you talking about the top point of that average line?
Yeah,
Yeah, okay. 42.
42. That'll do me.
Important to be accurate if you're asking me.
Then if you go to figure 5, please, on page 46,
Yeah.
and you look at conditions
I need to get there first. Yes, I've got there. Yeah.
of alpha is 0, that is the unbroken blue line, am I right?
Correct.
And you look at about the same wind speed. I can't be that precise, but about the same wind speed. It is clear that the background noise level is certainly in the high 40s, edging towards 50. Is that correct? It's higher than 42.
Maybe that's the order.
I'm sorry, I'm looking. the wrong line, I've been told. My apologies.
Sorry,
No,
Mr. Trilling.
just get the question right, so
Sorry.
you're answering the right question.
Yeah.
It's not the unbroken blue line. It's the alpha is 0, so I'm following the right column down and assuming that it follows what the lines. It doesn't. Alpha is 0 is the second line from the top, isn't it? The one with green dots. That's
Correct.
alpha is 0. Is that correct?
That is correct.
Right. So if you read up from just under 10 metres a second, it doesn't matter to be accurate for the purposes of this question. We can see that the background noise level is well over 50. Do you see that as a matter of fact?
I do see that, as a matter of fact. I need to ask why you're reading up at 10 on that scale.
If you look at whether it's 9.5 or 10, doesn't matter.
But why are you reading up at that
Please
level, sir?
wait till you
Okay,
get the
but I need to
question.
understand the question.
Well, you haven't heard it yet. The reason I draw attention to these points is that I would have expected that in conditions of alpha is 0, the background noise recorded on figure 7 would be the same as the alpha is 0 figure on figure 5. Why are they different?
Okay. Sorry, I've been corrected by my counsel, and I apologise for the way in which I perhaps have been answering a few questions. On this,
Accepted, and thank you, as generous.
Yeah. On figure 5, if I can go a little more slowly, and the reason I was asking why you were picking round about 10 is we're talking about completely different axes, and this is an error which I have commented on that Dr. Mackenzie has used in the past, because we've confused standardized 10-meter height speeds and actual 10-meter height speeds, and they are different. They are different axes on these two graphs.
Well, sorry, I'm not sure I understand that, because the height doesn't matter in conditions of alpha is 0.
No, it's not the height. It's what wind speed we are looking at. On figure 6, the figure we were looking at, it is 6, is it, or 7, whatever it was, 7. On figure 7, we were looking at actual 10-meter height wind speeds. I mean, all this is part of the confusion that the GPG has introduced to this whole thing. But anyway, we were on figure 7 looking at actual 10-meter height wind speeds. On figure 5, we're looking at standardized 10-meter height wind speeds, and they are different.
Yes, I see that, but in our conditions of alpha is 0, it makes no difference. That's the point. Alpha is 0. It doesn't make a difference, and therefore the figure should be the same. The x-axis doesn't matter. Alpha is 0. So why are they different?
I think the figure, let me just look carefully at this and think about this, please. I'll tell you why. Let me just think about it. I must apologize, but the apology is all based on GPG, because I've said before, GPG really confuses matters. Acousticians get confused. I can get confused. So I apologize for getting confused, but I do need to stop and think carefully. When you have 0 wind shear, then you are correct. The hub height wind speed, the actual hub height wind speed, and the wind speed at 10-meter level are the same. But what is being shown on figure 5 is not the actual 10-meter height wind speed. it is a wind speed at 59 metres, which is then corrected down to 10 metres using a standardised wind shear of 0.16. That is not giving us the same information as on figure 7. And
Well,
that is all the confusion of the GPG method.
I'm not sure, bearing in mind yesterday's examination and the day before, that agreed, because you acknowledged yesterday that when you're looking at a standardised V10 wind speed, you are looking at hub height wind speed. We acknowledge that.
Absolutely.
Yes, so they are the same thing. And therefore...
No, they're not the same thing. I beg your pardon, but they're not the same thing, because the hub height wind speed is not what is shown on this horizontal axis.
No, bear with me.
Sorry,
please,
yeah.
Bear with me.
Okay.
Look. We went to APP, well, I took Dr. Mackenzie to APP 21. I didn't need to take you there because I thought we'd got to the point that when you're looking at 10 metres in conditions of alpha is 0, actual 10-metre wind speed, hub height wind speed, and standardised V10 wind speed, because that equals hub height wind speed, will be the same thing.
That is incorrect.
Well, you have to explain why, given your earlier answers.
Yeah, I'm happy to do that.
So that narrow point, please.
Yes, absolutely. When you are at 0 wind shear, and you are talking about actual wind speeds, not standardized, actual wind speeds, the hub height wind speed is the same as the 10-metre height wind speed, but it is not the same as the third element that you quoted in your question, which is the standardized wind speed. Because if we turn to figure 21, may I take you to figure 21 perhaps, if that'll help?
APP 21.
Figure 21 in my report.
Figure
here.
21 in your report.
Yeah.
Yes, of course.
See, some of the evidence, while I'm trying to find it, some of the evidence that I put forward, for example, by Stigwood, and he commented on the GPG method and the confusion that it introduced for everybody.
Is this page
including
98? No, it's not page 98. Sorry. No. Figure 21 you want.
Yeah, actually I should.
97. Right, okay.
Okay. So, what we're actually saying in figure 7 is when we're looking at a 10-metre height wind speed of whatever it is. Let's pick 14 well, you pick 10 in that case. Let's pick 14 metres per second, because that's what is illustrated on this figure. So, the solid black line is 14 metres per second at hub height of 59 metres. It is also 14 metres per second at actual 10-metre height. Correct? You follow me so far?
Mm-hmm.
But standardized is not the same. Follow that dotted line down. You find standardized 10-metre height wind speed is at about 10.5 metres per second. Very different. That is the reason for the difference in the question you asked me.
Well, I have your answer, and I can submit, because we're not going to agree on this point.
No, we need to agree on this, sir. We do need to agree.
No,
Otherwise, you're proceeding without understanding.
No, we don't
the
need
essence
to
of
agree.
this.
There are lots of things we're not going to agree on, Mr. Baker, throughout this examination.
Do you understand it, sir? That's the important bit.
Right, thank you. So, to recap,
You do, sorry? Yeah, do you understand it, sir?
Standardized V10 by applying an arbitrary or a nominal figure for alpha of 0.16, I think it is, and that therefore you can't assume that V10S will equal hub height. it only equals hub height if that, in reality, if that wind speed happened to be, that wind shear exponent happened to be the actual wind shear that you're experiencing. It might apply at that one point, but not necessarily. V10S doesn't equal V10 necessarily. It could.
It never pretends to. No, this is an important point, sir. It never pretends to. V10S is only ever what you would get. It's like a pretend world, if you like. If wind shear was only ever at 0.16, what would you get corresponding to the wind speed at hub height? That's all it is. So it's a means of whatever. Anybody who quotes to you a V10S speed at 10 meter height, you can always, from that, know what. It's never the same as hub height wind speed. Never, ever. But from that, you can get what the hub height wind speed is. And as Dr. Mackenzie very rightly said in his presentation, it's a measure of hub height wind speed. As Hayes Mackenzie said, in the edition that the late edition that they put forward and we agreed on yesterday, you can translate that more sensibly into the actual hub height wind speed. So we could forget all about in a real updated world, we could forget all about standardized. We'd only talk about actual hub speed. But the standardized 10 meter height wind speed is never ever the same as the hub height. When you move into the real world with actual 10 meter height or any other height wind speed, only in those conditions is the actual 10 meter height wind speed the same as the hub height wind speed.
Right.
Sorry, I just want to make sure that
okay.
Understands. Thank you.
So you have to recall, clearly we do disagree on this in conditions of alpha equals 0. And that's the important
I have
point.
to express my
Thank
surprise.
you. So, to recap, it seems to be your approach based on figures 5 and 6 that background noise is only affected by wind shear and V10 standardized on site. Nothing else could affect background noise at core glass. That seems, it has to be the case.
I haven't actually said that nothing else can affect background noise at core glass. That's not what I have said. The reality is, the real world, you get a lot of variation in things, but on the whole, I have no evidence that there is consistent variation of wind speed at core glass and wind speed at the, and therefore wind speed at various heights for ground level at core glass and at the wind farm. And what the process that I have gone through, including the very last plot that I presented yesterday, there is a consistency that comes through all that approach. And it does not indicate to me that there is any wildly different wind shear profile at core glass than there is at the wind farm.
Yes, sorry,
I cannot say that accurately.
I'm talking about the background noise curves that we see on, say, figure 6. Figure 6. They are constructed purely on the basis of plausible lines relating to wind shear. They don't take account of other influences on background noise, such as wind direction, turbulence, variation of wind speed, variation of local wind. This is simply wind shear, isn't it?
Those lines are simply wind shear. They do take account of wind direction to the degree that Hayes Mackenzie do, which is plus or minus 45, which is a reasonable thing. We're only ever talking about that. So we all know the reality of variations, and we're talking about averages.
Right. Nevertheless, the report didn't make a note, can't he, that figure 6, the lines there are purely a relationship with wind shear, background noise and wind shear. That's the relationship you describe.
Yes.
Is that correct? Thank you. in reality, at Cordlass Farm, background noise will be affected by other things such as turbulence, wind in the trees. If it's a gust,
that is
no,
background noise.
yes, background noise.
Yeah.
If it's a gusty day, other things than wind shear will affect background noise levels at Cordlass Farm, won't they?
Other things than wind shear will affect background noise. That is always the case
Thank
because
you.
ETSU, etc., deals with average conditions. That we all know the reality in life. You get turbulence, you get gusts, you get anything. And that's
So
all
your
built
answer
into
is,
the ETSU
trying to
approach.
move on, your answer is yes, that'll do me.
Yes,
Thank you.
yes,
Right.
yes,
Go back to figure 6, would you?
yeah.
Now, I want to get clear. You're saying that any of the grey dots, the total measured noise between AA and BB could possibly be wind turbine noise. Is that right? Oh, sorry, they could be, my apologies, I phrased that wrongly. They could either be noise from the wind farm or their wind noise, the one or the other.
That's correct.
Thank you. And we know that the red dots are only wind noise because that's shut down. You also say that wind shear cannot plausibly be less than 0.07. That's the line you have there, I think.
It's a minus 0.07.
Minus 0.07, I apologise. Why minus 0.07? Why is that the lowest possible?
I have not actually said that.
Okay. It's the lowest you use, but...
It's the lowest I illustrate on this figure, and the reason I use that particular line on this figure is that this particular plot is for night hours, and the LiDAR data shows minus 0.07 as the lowest, I believe. This is all a long time ago, but that's where that comes from.
All right. And you say that all the grey dots above BB are largely wind farm noise. That's your pink zone.
That is correct.
Okay. So can we just go to page 48 of your inquiry report in that case? I'm in need of a comfort break anyway.
Yeah.
I know it's not
one
an
of
entirely convenient moment, but I think this is a convenient moment for me.
Yeah.
I would endorse that, sir.
Good. We'll come back at 11.
15 minutes?
Yeah.
Yeah,
Brilliant.
Thanks. On a slightly incorrect assumption in terms of the x-axis in figure 7, and hence the point I put to you. It's only fair to say that we've looked at that, and you're right, we're wrong. Okay? If you go to page 64 of your inquiry report, still with our mind on figure 6 and on the pink zone, page 64 and figure 17, we can see that what's at the top is there remains some uncertainty in the line that bounds the base of the pink zone, and what was largely wind-form noise coming down to minus 0.07 wind shear exponent is now sort of variously intermediate and moderate, etc. This is after your use of the data, which you, in other words, that is post the trial and error stage. Is that right?
We don't actually know precisely, but bear in mind that this figure is headed all data, and therefore this figure will include the daytime and the afternoon when you will have lower values. So that's why, and of course the red plot with the hatched values would include that, whereas the green circle data, which is the night, are lower, and that wouldn't be the
All
case.
right. Well, that's noted. We go back to figure 6 now. Go to figure 6 on page 46 again. Would you also get out the CD 111, which is the July 2019 updated noise assessment? It's probably best if you get a hard copy of that if you can.
Quite sure why I can't. The July update. No, beg your pardon. I've got it. Don't worry. Yeah.
When you get there, you want to find page 11 and then turn on 2 pages.
Yep.
It's figure 1. Noting that we've just been to figure 624, so when you say largely wind farm noise, there is an acknowledgement that we're not quite sure what's happening in that pink zone. Some bits wind farm noise, some bit maybe background noise. Let's compare figure 1 in the July 2019 additional assessment with the pink zone. Because you can see, I think, that at wind speeds, and we are comparing like with like, that standardized wind speed in the x-axis, that between about 4-ish, actually under 4, 3.5-ish meters per second, and roughly 6 meters a second, that there's a lot of background noise there, isn't there, in figure 1?
Yeah, is that question answered? Would you like me to answer now?
And therefore, it underlines the point that we don't really know what's happening in the pink zone when you say it's largely or maybe wind farm noise. It could be one or the other.
Not on the basis of this figure that you pointed to. And the reason for that is when all the relationships that I have produced are valid only for one monitoring point. So they are valid only for the 2018 monitoring point, because that's where the noise, on the background noise on which they are based, that's where all these figures come from. The 2001 location is completely different, and as I have pointed out on more than one occasion, is exceptionally loud for a typical sampling of a quiet amenity area on the property. Therefore, any points on this plot that you refer to are completely irrelevant for comparing with the points that are shown and the plot in my report and the plots in Hayes Mackenzie's report. There are 4 different locations.
Well, we'll come to your background noise monitoring location later. Just record here.
Sorry, this is not my background. 2018, sir, is Hayes Mackenzie's location.
Measuring location. We'll come to that later. But I still suggest that there's a reasonable comparison to be made between the 2001 background noise data, as I've suggested to you, and the spread of data, which might be wind farm noise, it might be wind noise, we don't know, in the pink zone. But you obviously disagree.
Yes, I do, and I could comment in answering that as to why I disagree, if I'm permitted. Okay. You were quoting where, about 5 or 6?
Between about 3.5 and 6 metres a second.
3.5 and 6. Okay. So can we take 5, for example, which here is just under 35? And I commented that this was recorded 2 metres away from trees. If we double that distance and we go 4 metres away, we would drop that point by 6 dB. If we went from 4 metres away, and this is all theoretical, of course.
It is,
I'm
indeed.
corrected, yes. But it is what's commonly said. If we double that distance again, we drop further. So, I mean, this is one of the reasons why this plot is different and is not applicable to where we were recording noise, or Hayes Mackenzie were recording noise in 2018.
Okay, well, we record to you, so we certainly don't agree with that point about noise levels dropping, as Mr. Baker said. He's given his evidence. We understand that we don't agree with that, and we think there is a comparison to be made. Go to APP 22, please, at figure 1.
Could you tell me what APP?
Sorry, yeah, it's the the measured noise levels during grid curtailment. Figure 1.
Yep.
This is night hours. And you look at 5 metres a second. See the highest plot at 5 metres a second is about 40 dB, isn't it?
Yeah, sure.
And that's at a distance 600 metres closer to the wind farm than Cordlass Farm. As a matter of fact, that's correct, isn't it?
600 metres closer?
Closer to the wind farm. 600 metres from the wind farm.
Yeah.
And there are no trees at that location. We can agree that as well. Yeah?
Yeah.
If we look at...
I believe so.
Okay.
I haven't been to it.
Okay. If we go to
Right, okay.
figure 6 on page 46 again and look at 5 metres a second, we can see this data up to somewhere between 45 and 50 dB, can't we? Measured data.
Yes.
Not the derived line, but looking
Yes,
at the
yes.
highest plots.
Mm-hmm.
2 points arise from that. Firstly, whatever your feelings about ISO 9613, it cannot be that wind turbine noise is higher at Cordlass Farm than it would be at the measurement point 600 metres from the wind farm.
I disagree. And I can explain why if you would like me to do so.
So you're claiming that wind farm noise can be higher at Cordlass Farm than at a point 600 metres from the wind farm?
That is not what I said.
Oh, well, that was the point I put to you.
Okay. Right. I thought what you said was, and apologies if I got it wrong.
It's all right.
That I was effectively saying, because we have a much higher points noise at Cordlass, that means, and we compare that to figure 1 here, which is ISO predictions, that it is completely illogical to have much higher noise at Cordlass Farm than ISO would predict at 600 metres from the wind farm.
No. Let's start again. Let's start again. Make sure you get it right. First of all, it's not an ISO prediction on figure 1. These are measured plots. I'm looking at 40 dB at 5 metres a second. Yeah?
Yes, I only add that I thought, and please correct me if I'm wrong, that Hayes Mackenzie was saying that this was actually, this plot and the average line through them was actually consistent with an ISO prediction that they did.
Well, try not to second guess too much. Just listen to the question. I haven't said that, and you're sort of going beyond me and second guessing where I'm going, which is just going to lead us into a
I'm trying to follow you, sir.
Well, okay, I'm a much simpler person than you think, okay? If you go to 5 meters a second on figure 1, this is simply measured data, and there's a plot at 40 dB. That's about the highest.
Yes.
If we go to figure 6, in the pink zone at 5 meters a second, the plots go up to somewhere between 45 and 50 dB, roughly. My question then, and if I put it wrongly, my apologies, it cannot be, as a matter of physics, that wind turbine noise at Cordglass Farm will be higher than at a measuring point 600 meters from the wind farm.
I disagree, and I can explain why now. And I shall do so if I'm permitted. Right. Now, what is shown on figure 1 is what was recorded quite correctly, as you say, 600 meters from the wind farm. It was during a period when I have been advised by Mr. and Mrs. Bonzio that the wind farm was unusually quiet. They did not hear wind turbine noise over that period when the monitoring was going on up there. And that, if I may add, I do have a slight criticism of Hayes Mackenzie, because they did not advise that they were doing that monitoring then, or liaise with the residents, and therefore they are not actually doing what ETSU asks you to do, which is to check and advise.
Can we just stick
Okay,
stick
I
to
will.
the facts,
I'll finish
please.
that. Yes. So the point is, we are not comparing like with like. We are not comparing with the data that's represented in figure 1 the range of atmospheric conditions that causes the problems at Cordglass. And if you actually go on to my figure 20, is it 21, whichever the figure I showed yesterday with the actual noise results, we do find results that do agree with ISO prediction, and those results, an ISO prediction, would I understand it, agree with what's shown on figure 1. What we are saying with regard to Cordglass is in certain atmospheric conditions, we get much higher noise. And the evidence that Mr. and Mrs. Bonzio gave was that during this period when this monitoring was going on, they did not hear the wind farm. Therefore, there were not in place the wind conditions that gave rise to the problem at Cordglass. And that's why there is potentially a difference.
Right. I think we're on different tracks here. Looking at 4.5 months of data taken at location 1. This is the sum total of that data for that wind direction. And the highest plot is at 40 dB. Mm-hmm. So 4.5 months data.
Sorry, how much data?
4.5 months of data.
Is it?
Yes.
Well, I don't know. I haven't checked. So
It's 4.5 months of data.
I would need to. In fact, we have not been provided, of course, with the details on that, but never mind.
It's in the report. If you want to read it, it's in the report. 4.5 months of data.
Yeah, okay.
40 dB at 5 meters a second.
Mm-hmm.
If you go to figure 6 on page 46, 5 meters a second is between 45 and 50. Now, let's get back to my question. We'll talk about wind turbine noise, which is predicted using the ISO 9613 model, which we explored yesterday.
Yep.
It cannot be that wind turbine noise is higher at 2.4 kilometres than it could be at 600 metres. It's
Why
just
is that,
simply the physics of the ISO 9613 model.
I disagree, and I will turn you back to Ullund. And if you look at Ullund, there were 2 sites monitored there, and one was between 600 and 800 metres, and that found no significant increase over the normal predictions. Whereas the other site, which was in excess of 1,000 metres, there was a range there, and that's where they found the figures that we discussed earlier, which are higher.
Yeah,
And therefore...
Just stop you there, because they're going off on one for this reason, that the APP 22 deals only with downwind data. That's downwind data only. That's the wind directions 190 to 316 degrees downwind. So I don't accept your point.
So was Ullund.
No, it wasn't, as we discussed this morning.
I'm sorry, sir, but I have to say I think you have, on your side of the room, I think you have the wrong interpretation of upwind and downwind as shown in Ullund.
Well,
so
I'm not going back there.
We need to disagree.
And the reporter has a nota where we disagree on that. The fact of the matter is, for APP 22, we're dealing solely with downwind propagation.
I'm happy
And
to
in
go
those
back to Ullund.
circumstances, I must just suggest one more time, and take whatever answer it is and move on, that it is inconceivable that wind turbine noise at 2.4 kilometres is going to be higher than that at 600 metres from the wind farm.
That I need to disagree with for the reasons I have said. And those are twofold. One is that during the period that monitoring was going on, Mr. and Mrs. Bonzio advised that the wind farm was uncharacteristically quiet. They did not experience the problem at Coglas, and therefore it's not surprising that the same or similar problem would not be experienced closer to the wind farm. So that is potential reason number one. Potential reason number two is what is in Oland, which we have been disagreeing about, and I would be very happy to go back to it, because that horizontal scale says very clearly, it does not say anything about upwind or downwind. It discusses only what the vertical profile, wind speed profile is. And that has
We're
been
not going back to Ireland, I promise you.
Can I just on Oland, I don't want to go back to Oland again. I understand where you're coming from on Oland. As I understand it, Oland found closer to the wind farm, there was less variance from what you expect to what you get. And whereas further away, there was more variance. And
that is correct.
His suggestion was the effects of the atmosphere on propagation were more pronounced as you get further away.
Yes, yes.
But, and I may be completely wrong, that takes you so far. It doesn't take you to the point that Mr. Trinnig is trying to get, which is, can it ever be possible physically for it to be louder an extra 1.5 km, 2 kilometres away than it is closer? I understand your point about maybe some weird differences in atmospheric conditions, etc., over the 4.5 months, but setting that aside, are you saying that Oland actually allows for the possibility that it could actually be louder 2.5 kilometres away than it is nearer as a result of atmospheric effects?
I think that is a possibility. When you look at the data that I presented in figure 21 with what is observed at Coglas at the time when wind farm noise was actually being experienced, and the official monitoring that went with it, there were results there which were substantially above what the ISO prediction was by quite a huge amount. And therefore, that says to me that I cannot answer to say, no, it's not possible to get higher noise at core glass during that period. But it would have to be monitoring at core glass that matches the atmospheric conditions that are in this set of data. And what was the actual period? If I
4.5 months.
No. That's the length of time, Mr. Trinick. What was the actual, in the year, from when to when?
I'll give you that in a moment. 22nd of March to the 31st of July.
Okay. What the experience that the Bonzios actually have, and I believe that this is not uncommon elsewhere, is that these problems are actually more in winter months than summer months, and I know the period you're talking about is not in the heart of the summer, of course.
It's not, sorry?
It is not in the heart of the summer, but it is equally not in the heart of the winter. So, I don't know. I can't comment what the variation in atmospheric conditions.
The basic physics are against you. I mean, you referred in this inquiry to a 6 dB reduction with a doubling of distance. If we were talking at the margins, something very small, well, possibly we could argue about thermal inversion, possibly we'd argue about a number of things. But I have to say it's fantastical, your claim, that you could have more wind coming from a wind farm at 2.4 kilometres and 600 metres. It simply doesn't bear any inspection.
Well, I think so. The atmospheric conditions that cause the refraction and the experience that's been found elsewhere, I think that is possible. And I think that the experience on figure 21 says that it is possible. And I think that the Bonzios, what they have related, that during that period of time of monitoring, they did not hear noise from the wind farm. So all those things taken together says to me, yes, it is possible.
I see. Well,
because we're not
have your
comparing
answer.
like with like.
I'll have your answer. I want to go to one of your slides. So I'm going fast as I can, but it's still some distance to go, I'm afraid. That is figure 6, which is at slide 14.
Okay, I have figure 6 in front of me in the report. So
Well, that's okay.
Thank you.
If people want to go to figure 6, that's, I'm using the slide because I made notes on it.
Sure.
That's fine. But you also have beside you the October 2019 monitoring report, which is CD 721.
I think I might have it
Let's
here.
take
October, I do.
When you get to that report, turn to page 21.
Yes.
Now, on figure 6, the blue line is a best guesstimate by Hayes Mackenzie of wind turbine noise in circumstances where they said in their report it's not possible to reach conclusions because of the poor signal-to-noise ratio about what was turbine noise and what was background noise, and that is why they made more measurements at the remote location where the signal-to-noise ratio was better, and there we have the October report. I just want to compare between figure 6 and table 2 on page 21 of the October report. You'll see the second line up is extrapolated wind farm noise level at Cordlas Farm, so that acknowledging the conversation we just had and setting that to one side, this is what you would expect at Cordlas Farm at a greater distance. And my suggestion is, if you compare what is shown for 6, 7, 8, 9, even 10 meters a second in table 2 for extrapolated noise, with the blue curve, the best guesstimate curve on figure 6, they agree pretty well. That's my suggestion.
Yeah, and?
Well, no, Mr. Baker, do you agree?
I do agree. I'd like to know the point of the question, please, because I have pointed out. May I?
No, you may not. You've answered my question. Thank you.
Okay.
If Mr. Campbell feels I've been unkind, he will no doubt re-examine. But I want to move on to slide. I'll come back to this slide, but I want to move on to slide 25. I'll tell you what that is, which is figure 19A. This shows Hayes-Mackenzie measured noise levels during periods when iPhone measurements were carried out, being the green dots. Is that correct?
That is correct. Sorry,
As I understand...
What page was... Oh, you've got the other... Sorry, I'm just trying... Yes, I am there. Thank you.
So the first point is all of these dots, including the green dots, are total noise, aren't they? We don't know from this chart, this graph, whether they're turbine noise or wind noise. We know what your evidence might be. They might be, but we don't know, do we?
Well, we certainly know that the Bonzios would most certainly know if the wind was blowing at the speeds that are necessary to make these points wind noise rather than wind farm noise. And if they were, then they would not hear the turbines.
Wow.
Very simple.
No, you may think it's simple. Let's interrogate this just a moment. That plot, before it was coloured green, was just simply a measurement of total noise.
It is.
It's been coloured green because for the relevant 10-minute period, Mr. Bonzio was outside with his iPhone. He's captured the time, so there's a correlation in time between what he heard, what he recorded on the iPhone, and the 10-minute period of Hayes-Mackenzie's measurement.
That is correct.
So we can accept that that green dot is a correlation in time we accept. That's fine. Yeah. But all that we know is that Mr. Bonzio heard noise. We can't tell from this plot that that green dot is necessarily where wind turbine noise is predominant. We don't know. It's just total noise.
That is correct. One does have to use one's intelligence and match with certain other information that has been provided by the resident.
Right. Thank you for that. Second point arises from this figure 19A, relates to, and I don't want to go into grid curtailment any detail, but I just want to cover one point here only, and that is that for these stall-regulated machines, it isn't the low-speed operation itself which causes the problem. If Hayes-Mackenzie are right in their diagnosis, and I know you don't accept it, it's low-speed operation during high wind speeds when the machine enters its stall condition, but wind speeds continue to increase with the machine being held in low speed, and that's what gives rise to the noise. So it's only those higher brown triangles, wind farm noise, low speed, which give rise.
That's
Listen, please.
Sorry, I beg.
I have to repeat the question, otherwise I'm not sure I can.
Sorry.
So it's only those brown triangles at higher wind speed which cause the problems. Other lower speed operations, such as seen at 8 meters a second, 40 dB, there's a brown triangle there. That's not a problem. It's only the constrained operation which gives rise to such difficulties as Hayes Mackenzie have diagnosed. Correct?
May I just enlarge this so I can see where all the triangles are?
Yes, of course.
Yes. No, you're absolutely correct, and that is something that I hit on already. If you've got a two-speed machine, you're only going to turn on to low speed somewhere halfway through the range. And I think that is why you only see these solid triangles starting from about a standardized speed of 9 meters per second up. You don't get them before that because basically before that point, the turbine would be operating naturally.
Normally, yes.
Normally up to that point,
yeah.
yes. So you're absolutely correct on that.
So it's the abnormal operation which triggers these higher plots.
Yes.
Okay,
Yes.
we agree there. This is fantastic. 3 points
It's
of agreement.
brilliant.
Oh, it's going well. Right. I want to turn now to page 66 of your inquiry report.
So my apologies, I'm a little slow getting from point to point because of my problem with my shaky right hand, so sometimes yeah, all right, I'm on page 66 now.
Thank you. At the bottom, you say in Table 4, using HM noise data reported against V10 standardized, I think that is, isn't it? V10S.
V10S for standardized, yes.
Wind shear is calculated from 3.5, VP 3.5 and V59 wind speeds. The wind shear is used to estimate the V10 wind speed, and thereby the background noise, wind noise, is calculated using the background noise relationship derived above. The wind farm noise is then calculated by logarithmic subtraction. The top of, before we go to Table 4, at the top of page 66, you do fairly acknowledge the reported wind speeds are indicative only. Therefore, they do accord, nevertheless, they do accord with Mr. Bonzio's qualitative assessment of wind speed according to the Beaufort scale. So, with that in mind, let's just go to page 67 and Table 4.
Sorry, may I reread the full bit of what I wrote? Because I
Yes, of course.
don't. Yes, all right. Oh yes, okay. Yes, I'm with you now. Yep.
So if we go to Table 4 on page 67,
Yes.
this seems to take either estimated Beaufort scale wind speeds or measured wind speeds. I think, am I right that no, I've got to get this right, that the estimated speed is when the anemometer wasn't in proper operation, is that right?
Yes, it wasn't operational. He was just estimating from the Beaufort scale down to that solid line across. Yeah.
And V3.5, because the clamp slipped, it was 4.5, but actually it's at 3.5.
That's correct.
That's fine. Go to page 65 of your inquiry report. I should have gone there first, my apologies. The anemometer which was used at 3.5 is not a calibrated device that would comply with normal monitoring requirements. The wind speed report is a typical wind speed over the 10-minute period, is not a numerically derived average. So, very fairly, you're not claiming great accuracy
Absolutely.
for this exercise.
Yes.
And certainly, the Ventus W820 weather station, which includes an anemometer, is not calibrated as LiDAR would be.
That is correct.
Yeah.
Yeah.
And what we have is a typical wind speed over a 10-minute period, not the average. So what I'm not quite clear is the sampling process, whether we will, I know you're going to cut in. Hang on.
No,
That's all right.
I'm waiting.
So we could be having either a high or low sample wind speed. We don't know how the sampling was taken.
That's correct.
So how was it taken?
Well, okay. One comment on that is what we're doing here, no, it is relevant, sorry, but it is in what's known as stable wind conditions. And I believe, and I could be correct, but I think when we're down at those low speeds, we're not having huge variations in wind speed. They do have a certain similarity to their description, stable. And Mr. Bonzio is looking at the device on which he has wind speeds recorded. He sees how much they fluctuate, and he said, well, this is a reasonable indication of what the wind speed is at the time he's looking at it. So that's all it is.
Okay, but actually, the trouble is that wind speeds so close to the ground are affected by other things than stable atmospheric conditions. In fact, far more so close to the ground, my suggestion is, by wind in the trees, by gusting.
Wind's not affected by wind. Wind is wind.
No, hang on. Over a 10-minute,
sorry.
Over a 10-minute period
Yes.
where you're not averaging and you're just taking a sample, a gust of wind can make a difference to the wind speed. If you're not averaging it over 10 minutes, you get what you get as a sample. We don't know what the sampling process is. There could be a burst of wind in the trees which causes noise and which you sample. We don't know. Do we?
We don't know, that is correct, but I have explained that Mr. Bonzio, he is aware of the importance of these matters. He is able to see and judge what is generally happening around him, and the description of what he finds is not consistent with conditions where he is experiencing gusts.
No,
they tend
those
to
are his
happen
estimates.
in the afternoon.
I'm looking at the measurements, not the estimates at the moment.
Oh,
Looking at the measurements.
yes.
Come on to the... Can we have some quiet down there, please? We're looking at the measurements, not the estimates. So we don't know whether the sample that was taken for any given 10-minute period was or was not typical for that period. It's certainly not average. It could have been a gusty period. It might have been quieter. It might have been affected by wind in the trees. It might not. We don't know is the answer. Correct?
That is correct.
Right. As to the estimated wind speeds, and we'll come on to those now, on page 67, second paragraph below table 4, the estimated wind speeds are values from the Beaufort scale. This scale gives estimated wind speeds 10 million. As this is a crude broad brush assessment, I don't criticise it for that, I'm just noting that's what it says. The estimated values have been increased by an adjustment factor such that the average wind speed for the estimated wind speeds is the same as the average of the measured wind speeds. Well, once I disentangled that, I went to your inquiry report at page 51.
The same report, obviously.
I'm sorry, I want to make sure I got the right reference here. It's not page 51.
Sorry, I'm looking for it. Do you do mean
No,
the same
I don't
report,
want you to look
do
for it. A complete mess up. It's not that at all.
No.
Let me just get the right reference here. I can do it without those references. If you go to DB32, which is one of your documents, DB32 we need. DB32,
The iPhone
yeah.
report, yeah. I can open it up electronically, but just
That's
it'll take
fine.
a minute.
No, that's fine.
Although if
So-
you tell me what it is, I may not need to look at it.
No, you will need to go there.
Oh, well, okay.
It's your noise monitoring by iPhone, 28 July
Okay,
to 20
okay.
August.
Right.
So when you get there, you want table 3,
Yeah. Okay.
which is the second page from the back. Actually, there is a problem with comparison here, Mr. Baker, that you'll need table 4 and the document side by side.
Right. Okay. I shall.
So can we supply a copy of DB 32
No.
to Mr. Baker?
No, that's very kind. Thank you.
Table 3.
I'm quite bemused. While we're waiting, I thought I could do this more efficiently by using go to and page and put in 66, but unfortunately, it doesn't work. So I have to do it the slow way.
As the DPEA generally know, I'm a great fan of hard copy.
Yes. Okay.
Have you got DB 32?
Yes.
And if you go to table 3 within it, which is the second last page,
DB 32, and I go to. Oops. Okay.
now,
Sorry, which table?
table 3. So the second last page of DB 32.
Yeah.
And have you got table 4 as well?
I'm just going to it now. Yes.
Now, if you look at table 4, the first entry for estimated wind speed is at 1554 on the 31st of July. You see that?
I do.
V3.5, 1.8 meters a second. Now, go to
In table, yeah.
table 4.
Yeah. Yeah.
Go to table 3,
Yes.
which is in DB32,
Mm-hmm.
for the same entry as 1554. Read across, we can see the qualitative wind speed is light.
Yes.
My second and final, I'm not going to go to all them, example is if you go down to the bottom of the estimated wind speeds,
Mm-hmm.
the last one for the 4th of August, 8:41, we can see it's calm.
Yes.
I had to ask myself, well, what does calm mean? So if you go to table 1 within DB32, which is 2 pages before, we can see that calm means 0 wind, smoke rises vertically, and therefore the 10-meter height wind speed is 0. That makes sense?
Yes.
Light is Beaufort scale 2, wind felt on face, leaves rustle, wind vane moved by wind, 10-meter high wind speed is 3.
Yes.
Now, that 10-meter height wind speed is obviously at Corlas Farm, isn't it? Has to be.
Yes.
Yeah. Who rated whether something was calm or light?
Mr. Bonzio.
How did he do it?
Judgment.
Well, I mean, I'm not being rude, but because I often stick my finger in the air when I want to know what direction the wind is, but it is just finger in the air time. All the smoke is rising vertically, therefore there's no wind.
Correct.
No, I'm not being rude, Mr. Bonzio, please. I'm
correct.
just trying.
It is judgment, which is what the Beaufort scale is all about.
All right.
Helping people get an idea. It's rough only.
And when we look in Table 1 as well, the double asterisk for by 10 metre height, and follow that down the page, we see at 10 metre height as the Beaufort wind force level speed at observer height 1.6, corrected to 10 metres. So what value at 1.6 is being corrected to get to 10 metres? What value? That must only be an estimate of what Mr. Bonzio thinks the wind speed is.
It is only an estimate, of course.
Yeah.
Yes.
But he's not estimating Beaufort scale there. He's actually estimating wind speed in metres per second. He has to be able to do that for you to reach a figure of 1.8 in light conditions on Table 4. That's the only way it happens, isn't it?
That's correct. It's judgment and judgment interpretation.
Fine. So
and
the
could be
1.
quite wrong.
My apologies. The 1.8 metres per second we see in Table 4 is corrected from a height of 1.6 metres on a judgment made by Mr. Bonzio of the wind speed.
That is correct, but the people who came up with the Beaufort scale and the guidance on how you rate it, they normally stand on the ground as well, so the two things are compatible.
Well, okay, I'm just finding out what happened. We go back to Table 4 on page 67 of your report. I can't see how we get to a V3.5 estimate of 1.8 metres per second from initially a judgment at 1.6 metres height corrected to V10 of 3 metres per second. How does that become 1.8 metres per second at V3.5? We have a puzzle.
Well, it's stated that, let me just have a look at this. On Table 1, on Table 1 it says that it's corrected using standard IOA correction for neutral conditions. And effectively that would be what was done here as well. It's using this, I think this was using the standardized. This is a long time ago. I think this was using the standardized correction.
Well, we don't know that because there's no reference to which IOA report they're talking about, and we don't know what neutral conditions means here, do we?
It is referring to the standardized correction.
Well, how do you know that? All it says is standard IOA correction for neutral conditions.
Well, I know that because I
But in which document?
I know that because I did it.
Yes, in which document? So you assumed, shall we cut to the chase, that it was a CD72 IOA GPG standardization. That's what you used, 0.16.
That is what I used at the time.
Okay, fine. So the process was, Mr. Bonzio, 1.6 metres, I think it's a wind speed of 1 metre a second, say, whatever he thought it was, corrected via 0.16 exponent to 10 metres, and then standardised back to 3.5. Is that what happened?
Yes. May I comment that this is a conservative exercise, because if the wind shear actually was much higher as expected, we would get a lower speed at 10 metres high. So this was a conscious decision I took at the time. I had to pick something, and I simply used. And there's not a big difference between 3.5 and 10 metres. So I've got to pick something. It was a reasonable thing to do. It was conservative. It wasn't egging the game with a high wind shear.
have your answer.
That's what it was.
So for 841, the other figure, on the 4th of August on table 4, we have a V3.5 of 0.3. How do you get that, given that the 10-metre high wind speed in calm conditions is supposed to be 0?
It's only a judgment. Someone says it's calm. That does not say I am precisely on that level of the Beaufort scale, nor does light mean I am precisely on that level of the Beaufort scale. There is an element of judgment, and my judgment was when the description calm was used, we should use a relatively low value. Approaching 0, I did not use 0.
Okay,
that's all it is.
I've heard what's been done. Okay. Looking at the figures for what you do is go from 3.5, V3.5 at Cordlass Farm to V59 on site. It's 1.8 to 12.9, and that gives you alpha equals 1. Is that correct? That's what you've done.
I will have compared the V3.5 at Cordlass with the V59 at the wind farm.
You see, I asked for a check to be done on this. I didn't put it to Dr. Mackenzie because I hadn't done this exercise by then. But I'm told that actually that's incorrect, that the that the wind shear factor you come up with if you do that exercise is 0.7, not 1. I'm not asking you to check it right now, but I give you a series of figures for that Beaufort scale part of table 4. So you might want to note them down, and then I'll come to what we're going to do about it. For the first entry, I'm going to...
Just a moment, if you want me
Yes,
to...
of course. Yes, of course. My apologies. Yeah.
Right.
So for the first red entry in the wind shear column of 1, we say it's 0.7.
Yeah.
For the second red entry of 0.9, we say it's 0.6. For the third red entry of 0.9, it's 0.7. And for the last entry, which is not red, the one I've been to already at 0841 on the 4th of August, we say it's not 1.4, it's 1. The measured data, we say, is being correctly calculated. So it's only for the estimates that it's incorrect.
Yeah.
Now, what to do about it, I'll come on to in a moment.
Yeah.
But I'll come on to it now, sir, because we are getting near the end. But I guess we've got another 20 minutes or so to go. I'm happy for not to waste inquiry time, but to allow Mr. Baker through Mr. Campbell to respond in writing just on that point. It's a factual point.
May I respond now?
Well, if you've got an answer now, but I wasn't going to push you to immediately...
I think it's very brief. I think it's a very brief answer. And, you know, if I've made any mistakes in that section on the estimated ones, and it could be with I'll tell you what a possible explanation is when I put in figures for the V3.5, I may have, and I think I may have adjusted the estimated values based on, and I think I said something to that effect, based on the average of the actual measured one. And I suspect that that is where the difference comes from. But all of this it's indicative only. So the best indicative data is with the data where we actually have some measured values, the bottom half. And I think there's little point in pursuing this beyond that.
Well, if you're happy with that...
That's my explanation.
You can, it's up to you. It's not for me to make.
Anything in writing will simply, I think, confirm that.
Okay,
I won't waste my time doing any more counts.
So long as you understand that I may submit that you're wrong, I'm giving you a chance to correct it. It's up to you whether you take that chance or not.
Oh, if I'd like to correct. Yes, I could do that.
Well,
By
you
all
know,
means. Yes.
That's all I'm saying.
Yeah, thank you, sir.
Could you just give me a moment, sir? Yep, I do need to I'll just continue. Well, I'll continue to the end now, so it's not going to be that long. Sticking with your DB32, after the text, there are a series of plates and tables, and the first plate is plate 1, which is a photograph you've taken us to before. It's in your slides, showing the noise and wind monitoring stations. Looking at that photograph, we have the anemometer, or the weather station, including the anemometer, at 3.5 metres. And my suggestion is that quite clearly wind in the trees, when coming from certain directions, will influence that wind speed as measured at that height.
The wind, the direction from the wind farm is from the left, which is completely open. So the wind hitting the anemometer has not been slowed down by any trees.
Perhaps I understand what you're saying. Mm-hmm. We don't necessarily agree, but the trees in the background, when the wind is coming from that direction,
that's not
or indeed from the wind farm, which the wind farm's off to the left. Mm-hmm. We know that. Mm-hmm. But wind coming from the wind farm will also go through those trees and will influence, I suggest, the 3.5 metre wind speed.
I think in reality that is highly unlikely that there will be any significant effect. Because if I interpret what you're saying correctly, I believe you're talking about wind hitting the stand of Scots pines.
Yep.
As distinct to wind hitting this anemometer, which is a considerable distance away from there. And yes, of course, you will get some horizontal wind shear, if we like to use that term, mm-hmm. where the wind passing through the Scots pines is slowed down, and therefore there is some horizontal shear which will slow the wind down in between. But I would submit that the practical effect on the wind at the anemometer position is very small.
Well, we're not talking about horizontal shear, I'm talking about vertical shear. And my suggestion is that those Scots pines, and we can agree or disagree, we'll have to leave it there, those Scots pines in direction of wind coming from the wind farm will influence the wind speed at 3.5 metres anemometer.
That is an opinion, it's not one I share.
Fair enough.
It will influence to some degree. It's not one I share that the influence would be, in the scheme of things here, of any significance.
All right, that's your view. Thank you. Mr. Baker, thank you for your answers. That is the end of the cross-examination.
Thank you, sir.
I'll just check if there's any remaining questions that I have. Bear with me for a second. No, I think there's nothing else from me, so it's just whether Mr. Campbell has any questions for you in re-examination.
Am I permitted, sir, to just say one thing which I think relates to. It is brief. It relates to Dr. Mackenzie's reputation and my own, following one of the questions we had. I think it's important just to say that what went out on air verbally, which people are going to look at, is without the benefit of the very carefully defined wording in my report. So when we talk about something being either bias or corporate incompetence, without the definition in my report, that sounds potentially very bad, and I would just like to clarify that. It's basically a scale. One end is, and this is only ever an opinion. It's my opinion as an expert witness. There are three ends to this. One is an assessment that I would say looks to me 100% professional, balanced, no bias. The other end of the scale is something that is biased in favor of the applicant. In between, if there is something that doesn't fall in the clearly this is a totally professional judgment, then it has to come somewhere between the two that I've defined. And it's important, and I think I should go to my report and for the record just define what corporate incompetence is.
We can look at the report.
Yeah, the point of this, Mr. Campbell, sorry, was to get on air, because people who look at this, and they will look through all the sessions, they don't plough through the supporting documents.
Okay. I'm content that you want to go on record as saying you're not, you didn't want there to be any suggestion that you're alleging anything untoward from Dr. Mackenzie. You're explaining at one end there's scientific perfection,
yes.
purity, etc.,
yes.
completely impartial. Yes. At the other end is something terrible. You're not suggesting he's at the terrible end, and you wanted to record that.
That is correct. And within my written bit, I do point out that there can be unconscious bias, if you like. So, yeah.
This is not an appropriate way to deal with evidence. Secondly, I have the answers I have on air, and on those answers on air, I rely. And this is not an appropriate way to end this session.
To be honest, if it helps, I'm not, as is typically the case, I'm not likely to be putting a huge amount of weight on this kind of exchange anyway, as to witnesses disagreeing with each other. It is what it is. I give value to the evidence that I have, and I'll make my decision on that basis.
But evidence includes the evidence, not only on air, but the written evidence you have, which I'm quite sure you've read, vast quantities there are.
The joys of being recorded. Does anyone like a short break before we talk about conditions?
Yes, there are no more, just for the sake of formality, there are no more witnesses for the objectors in this part of the inquiry, and we are much obliged.
Mr. Trinick? Yeah, quick 5-minute break, and then we'll talk about conditions. It probably helps if we just quickly rattle around the table to explain who everyone is who is wishing to take part in the session, just so everyone knows who's speaking. I'll start with the applicant's side of the table.
Thanks, Marcus Trinick. I'll be taking part. Nicola Martin may well take part. To her left is Ian Adams from Fred Olsen Renewables, and to my right is Dr. Mackenzie. So that's our mini team for this session.
Down the council's end.
Hello, yes, I'm Neil McPherson, Principal Planning Officer, Development Management, and to my left is Douglas Caldwell from the Environmental Health section, both taking part.
Mr. Campbell, is it just yourself? Or?
I've had the opportunity of recent date of inspecting the draft, which Mrs. Martin kindly circulated a day or two ago. At the present time, I don't have any observations upon it, so I'm here and I would take part if I hear anything I don't like the sound of, but other than that, not.
Okay, well, we might as well just dive in. I'm assuming I'm looking at the correct latest version, which is Noise V3 from the 18th of November. Excellent, that's a good start. We have some disagree. Well, we start with, might as well do it as we go through it. Condition 23, simply a difference of how amplitude modulation should be dealt with, whether it's best dealt with by submitting a scheme or alternatively how the council, I think, wants it done is something a bit more specific and written into condition 24. I guess, can I ask the council, really, what's your concerns about how the applicant wants to deal with it, which is simply by leaving it for now and getting them to put in a scheme, telling us how they're going to deal with amplitude modulation? Why do you want it up front, which I think is what you're wanting?
From the council's perspective, there is an Institute of Acoustics bulletin published November, December 2017, which is in play as a prescribed method of currently dealing with amplitude modulation. We've taken independent advice on the use of that type of condition and feel it is in play, it is useful. Within the later guidance notes, there is provision for if further amendments to that scheme come into play at a later stage, then there's reference to that. So we feel it adds detail. It is in place now. It has been recommended in other planning conditions rather than a suspensive type approach which is proposed by the applicant, which the detail of which we don't know yet. So we feel it adds a bit more in terms of precision at this stage.
Yes, I don't think we have any technical issue with the condition proposed by the council, and ultimately we can live with it. The reason for suggesting a scheme is that amplitude modulation is still an advancing field, and it may be that by the time any permission granted is implemented, science has moved on, and we wouldn't write quite what we would write now. That might be said we could do a section 73 variation, I accept that. But as a way around making another application, it seems to us better to have some flexibility built in as we suggest. It's as simple as that.
So then turning to the main noise condition itself, I think we're generally no problem, subject to removal of the reference to AM, if that's the way it goes. Everyone's happy, it's a standard condition.
Yes, except that, of course, if Mr. Baker's hypothesis is accepted, then this condition has no application. I'll just put that on record without commenting on it.
And then we come to some extra conditions that the council is requesting. So the first one of these, which I think starts on page 10, wind farm operator shall employ an independent consultant to measure the level of noise emissions within the first year of operation, unless it's an extended period is agreed. Forward the results to the planning authority. And so the applicant, you're accepting some need for this initial monitoring, but you're just proposing a slightly different form of words. Is that right?
I think it's more than that. It's the words in Murray's condition and every 2 years thereafter.
See, that's been crossed out, hasn't it?
Sorry?
The line's been put through that on my version.
Oh. No, it's not agreed. We accept that the request to demonstrate essentially compliance with whatever noise conditions imposed within the first year of operation. It's not standard, but we accept it. That's fine. But on every occasion you do this, you have to switch off turbines. Therefore, there is a cost to the exercise. There's a balance between cost and advantage, and for the first year we accept that advantage is struck in favour of compliance measurements. As I said, there is in the first year we accept there is an advantage in compliance measurement. Thereafter, the system should be complaint driven. We don't see that it's reasonable to expect. Once you've demonstrated compliance, machines are set up, they've been commissioned, and there's no physical reason why anything should actually change. If something did change, I've been noting these are pitch regulated machines and we haven't got the stall regulation problem that has been discussed in this inquiry. No reason why anything should change. Operators do maintain their machines in good order because by doing that they maximise their output. So it's not a question of wear and tear either. That's not going to happen. So we don't think it's reasonable or necessary to do it every 2 years thereafter. That's the difference between us.
Yeah, because my version has a line through and every 2 years thereafter. Which might have been Ms. Martin crossing it out in disgust, but
Sorry, sir, is that a manuscript?
yes, manuscript change. Yeah. No, that was you. That was your view. I'd assume that was the council's agreeing to that at the last minute, but evidently not. Can you explain why? The convention is you rely upon complaints coming in, and then you have to go out and investigate it. They're offering to do a bit more than that for the first year. Why is that not sufficient? Why do you want more than that?
I mean, the view it's taken, I suppose, this is typically a 25-year long-term development, which could be renewed thereafter. I'm not sure if the conditions take 25 years, but it's been a condition which we have commonly used. It's shared in benchmark with other councils as well. There is also within appreciating the fact there is obviously costs associated with switch off. There's further provision within condition to reduce significantly that frequency of retesting, which we have also done in practice where there's been considerable headroom for compliance. So perhaps you have the first year, you have within 2 years further test, and where we're satisfied there is no significant change from one test to the next, we're quite happy to let that lapse and reduce considerably. So we feel there is flexibility in terms of the amount of testing. We wouldn't suggest by any means it would be every 2 years for, that could be 12 tests over 25 years. That's not anticipated. Is it 35? Sorry, Neil.
It's corroborative. When you first year monitoring, then 2 years thereafter, further monitoring. It's just corroborative of the ongoing maintenance is referred to, ongoing operation of the wind farm. But obviously, as Douglas pointed out, we talk about every 2 years thereafter, or unless that is agreed. So, especially if there's consistency there, and that would inform a relaxation.
Thanks. I shall have a think about that one. And then some sort of wider noise conditions. Condition 3, construction works, including vehicle movements, shall be subject to some hour restrictions. This is not agreed. Yeah, I do remember this coming up. I'm trying to rack my brain as to what we talked about. The effect of this condition would be even vehicle movements would be prohibited within those, or out with those hours, if audible. Okay, probably easiest if the applicant explains. Effectively, I think your position is you think condition 16 is adequate, as was originally discussed. I think we discussed last, whenever it was.
Sir, condition 16 of the table that was discussed at the last session does provide for the hours to be restricted, and we see no reason why that what we thought was agreed and discussed at that session should now be changed. Those hours are set out in here and provide appropriate protection for nearby residents and allow the appropriate prior notification procedure if there's any alteration or any untoward circumstance that occurs that needs an exceptional out-of-hours work occurring. So I do have a hard copy of notes that were agreed of that table.
Turn to the council. Okay, so the proposed condition is somewhat more restrictive than condition 16. That sought to restrict things, but with some exceptions. It sought to restrict heavy goods vehicle movements, but not all vehicle movements, which I think condition 3 would restrict. So it's a fair bit stricter. Is this again a standard condition that you've used elsewhere, or is it a specific concern that you have with proximity to residents in this case, or why do you think condition 16 is not adequate, I think is the question.
Looking between the conditions, condition 16 and this draft condition, there does appear to be a fair bit of overlap. Really, I think I was just coming back to the point about wanting to, as we discussed in September, to make sure that trigger for HGVs and construction, things that are likely to cause most disruption or noise, are something that aren't just notified to us but are run past us, just to have an awareness of, and we can control that. One point, for example, in that condition 3 of the proposed conditions, in the top of page 12, for example, we've talked about, it's from 7 till 1300 hours on Saturdays, to be consistent with the other condition we'd see, and that's consistent with other guidance we'd see, 1400 hours. But I think there is a scope to merge those two conditions. I think it's just wanted to make sure, obviously we're coming from noise, we're coming from operational side, that there's a degree of control over out-of-hours working, construction and HGVs. There can be, our experience says there can be times critical times in the construction phase when quarry vehicles delivery have a peak of delivery and they're trying to build tracks, etc. I acknowledge this site isn't going to have the extent of tracks, but that tends to be our experience of trying to control certain construction activities and certain delivery of HGVs to the site at sociable times, or if they need to be out with those times, we can have that control. So there may be a scope to merge that condition 3 with the condition 16 previously discussed. We were certainly, as we mentioned in September, we are very accommodating. We understand that out of hours working has to occur. You have trains avoiding windy days and other things like that needs to occur. And we're generally very supportive when we allow out of hours working to occur when there's rationale to it. And it's just having the condition to make sure that we have that control, that we are, rather than being told about it, that we can control it. So that, for example, if all of a sudden we're having emergency concrete pours every weekend for months, we put our hands up and say, no, actually, that's, we need to control that. So not that that would be the case, but it's just that we need to have that control through the condition.
Sorry, can I just clarify? I think the core hours are 0700 to 1600 on Saturdays. We were okay with that rather than 07 to 1300. That helps.
So if I could just add that there is provision under the proposed traffic management plan for prior notification of delivery of aggregate and other construction deliveries to the site. So there would be a prior notification discussion for that side of the condition.
We would just wish that to be consistent with other conditions, for emergency works too.
Condition 4, construction environment management plan. I think the applicant's saying that's already secured by one of the existing conditions. I think nobody's saying you don't need one, but I think, yeah, that's fine. Right. Quite a detailed blasting condition. That's condition 5 and 6, in fact. And 7 and 8. You're going to tell me there isn't much blasting likely to happen?
Sir, that's right. The ES has considered what actual activity there is on site and the distance to the nearest residential properties. That's at, as it says on the table, chapters 412.1 and 413.1. The figure in volume 3, 1.2, figure 1.2, sets out the site layout, and the search includes search areas for the borrow pits, which were considered as part of the ES. There seems to be no necessity for this condition.
Really just where if any blasting is to take place, we would rather have some measure of control over that. And noting the distances involved and the level of blasting required, hopefully won't be an issue. But really, if you don't have a condition at all, and there's incidents, or there's any issue with it, and we had no measure, no means of controlling it. Or we could control it through legislation, environmental health legislation, etc. But we don't see any harm in having a condition where there's going to be blasting occurring, to have provisions in place to safeguard amenity in the event there's any issue.
Yes, please.
So that there is a provision already included in the SEMP, small paragraph C, condition 13 was discussed in September.
Know that. I think it's just very similar to the discussion we had in September about shadow flicker. Blasting will be fairly specific and detailed matter, and obviously Kemp covers quite a wide range of things under condition 13. We would just prefer to see that covered under an identified condition, so we can the various things that we're asking for, that those suggested conditions 5 to 8 are provided. Ultimately, whether it's in the Cape or whether it's a standalone matter, but the nature of the information that we're requesting in conditions 5 to 8, I don't think is necessarily flushed out. It's clearly in the Kemp condition, so it just limits, etc. You know, so, but whichever conditions in, the level of detail that we're looking for 5 and 8, just give us the comfort to control the matter in the event that it's an issue at all.
Mr. Trenick. Would you say the question for me in advising ministers is really it's the desire for you to have control, which I understand, balanced against the likelihood of it actually causing a problem for anyone, bearing in mind the incidence of blasting and the distance from a potential people affected by that blasting. Ministers will need to come to a judgment as to, given that it's, it imposes certain burdens on the applicant, are they too much of a price to pay given what might appear to be low risk of there being a problem? But is that the right judgment they should be?
Yeah, I think what it is that looking too closely at the test of conditions. Essentially, it's a precautionary condition, but it's a situation where if something were to arise, we have a mechanism to deal with it. It causes a problem. So I understand there's it could be a burden upon the applicants, but really not having, if there's only blasting at all, if you had a commitment that there was no blasting, then we would admit the need. But if there's no have to be blasting occurring, then we need to have some mechanism in place to address issues that are referred to in the condition, however unlikely they may be. It's not uncommon. Remember the old days we used to have a precautionary condition about interference with television receptions, which did cause problems occasionally, and had to have a condition to address. Otherwise, we're left mildly powerless. So it's really in the same vein, just having that mechanism there to control it in the event that it's an issue.
Shadow flicker. I think we have this. Oh, you've said agree. Yeah, we didn't forget about shadow flicker. And then we have a final condition. Oh, this is dealing with the details. You want to know up front which is the winning turbine, which one's actually going to get put in. Explain. I think I know what you're going to say. Explain to me why you want to know that.
Without repeating any discussions of the past 2.5 days, I think we need to have the definitive model and the properties of that model known to us from the word go. It's ultimately, I note that the comments from the applicant, they're concerned that we might overly constrain their model and its operation. It's really just it's as much as anything else to know the definitive model that we have, and that obviously would inform the monitoring going forward and the scope and operation of the wind farm, but it's really just that we actually know precisely what's going to get put in. And then I think Douglas is pointing out to me that that's in keeping with ECU guidance that we have. Condition 7 that we have that. Condition 7 that we've in the main table asks for the make and model, etc. But I think as we've learned from the inquiry, you can have the make and model, but it's the actual, maybe what's under the bonnet that matters, perhaps, in the case of the actual definitive model selected in this property. So just to have complete knowledge of what turbine actually gets selected and installed.
Well, there is condition 7 for colour and finish, clearly. I think we don't like this condition for these reasons. First of all, we see the reasons given by Murray. We understand them. That was then. That was in 2005-06, whenever the turbine was selected. Early days, stall regulator machines, which give rise to particular issues, as we now know. Now, any turbine selected will be of the modern pitch-rated variable speed type. Much more sophisticated, much more predictable than the earlier machines. Secondly, looking at what's actually required, power rating, I'm not sure on what basis the local authority would actually judge whether or not a power rating was acceptable. If it's 4 or 4.5 megawatts or 3.6 or whatever, that doesn't necessarily relate to noise and the noise output and the profile of that output across octave bands, etc. You can't make that judgment. Against the sound power levels with modern machines, the setup of the machine is as important as the choice of the machine, how you set it up to operate on a particular site. And that really is a matter for the developer. Tonality, I believe that Dr. Mackenzie has agreed with Mr. Caldwell that tonality itself is not an issue at any receptor. That's been agreed.
It was more that the tonality at the turbine could be very different turbine to the tonality at the receptor. That was we agreed that.
You've agreed that. Okay, well, I put it slightly wrong here. I apologise. So what that comes down to is that the local authority is going to get much more protection from the compliance testing. That's where the protection is going to come in. Modern wind developers, as opposed to maybe those we would try on an error basis of 15, 20 years ago, you're not going to select a turbine unless you are very, very sure it's going to work on site in the right way. That doesn't give total comfort to the bonziers or anybody else. I wouldn't expect it to, hence our offer of compliance measurement. But I think that's the way forward, not try to approve matters before the turbine's actually set up and commissioned. That's our reasoning.
It puts your mind to rest. I see the point you're making. Maybe a suggestion would be is that in the last sentence of that condition, where we've said have been submitted to and approved in writing by the planning authority, even if it's just submitted to the planning authority, effectively we just want to know. And I would take comfort from all the other conditions.
Yeah.
So we're suggesting is just that the actual details that are submitted to us. The concern I suspect is that we would then turn and say, well, we're not happy with...
We agree.
Yes.
Submitted to is fine. You know what you're getting. That's no problem at all. Yeah, I was going to suggest. I think it has to be, well, it's prior to the erection of any turbine. That's fine. But otherwise, that's a good suggestion. Thanks very much.
Conditions anyone wants to suggest? No?
I don't know if I wanted to say this, but I should, for your benefit. I know that in the inquiry in September there was some discussion, and it's referred to in some other draft conditions, about in the event of turbine 1 being removed. While we're here, should we think about that is that relevant to the noise conditions? Maybe it's not, but while we're here, I thought I mentioned it in case it was something that needed to be addressed. To my mind, to my head, I think the limits will still work, but I thought I'd mention it in case it's something that we should consider for this part of the...
Well, so I think it's a matter for you. If you reach the conclusion on landscape and visual grounds that turbine one should not be erected, happy to leave you to phrase it as you want.
Phrasing then. Good. I think that was all I had. Before I close the inquiry, any further matters anyone wants to raise?
Only to thank you very much for a very courteous two-part inquiry, also to my learned friend, and to wish you well with your deliberation.
Thank you.
Thank you very much.
Thank you very much. Thank you. Okay, inquiry is now closed. Thank you.